Welcome to the West Desert Amateur Radio Club's video series to prepare to take the Technician Class Amateur Radio exam. This is video number 16. This video will discuss the terms and names applied to electrical characteristics and measurements. So let's get some specific definitions of the terms volt, amperes, watts, and ohms. We'll start with the volt. Your electrical outlet in your home has 120 volts of power. So what does that mean? The term volt is named after the Italian physicist Alessandro Volta, who invented the first battery. Volts measure the electromotive force. For the precise scientists, 1 volt is the potential energy between 2 points that will impart 1 joule of energy per coulomb of charge that passes through it. Well, those are big terms, but essentially, in practical terms, volts measure the force or the push behind the flow of electrons. Volts are denoted by the letter V. The measurement is made by a voltmeter and is made in parallel with the circuit. Current is the actual flow of electrons in a circuit. The symbol for current is the letter I, and the amount of current is measured in amperes, denoted by the letter A, and it's just often called amps, A-M-P-S. Current is measured by an ammeter, and it's measured in series with the circuit. The name amperes is named after André Marie Ampère, a French mathematician and physicist. Current can flow in one direction, called direct current. It can also flow in one direction and then the reverse direction, called alternating current. The number of times a second that the direction changes is the frequency of the current and is measured in hertz, that is cycles per second. Power is the rate at which electrical energy is being consumed or used and is measured in watts. The precise definition is the rate at which electrical work is performed when a current of 1 amp flows across an electrical potential difference of 1 volt. It is named after the Scottish inventor James Watt, who's also the inventor of the efficient steam engine. Next, we have the ohm, which is a measurement of resistance. It is named after the German physicist Georg Simon Ohm. The ohm is defined as an electrical resistance between 2 points of a conductor when the constant potential difference of 1 volt applied to these points produces in the conductor a current of 1 amp. The symbol for ohms is the Greek letter omega, which looks kind of like an upside-down U. The resistance in a circuit is usually calculated, although the resistance of individual components can usually be directly measured with an ohm meter. Now let's put these 3 definitions into some kind of a context. Consider the diagram on this slide. Water is stored in the tank and represents potential energy. There is a small pipe coming out of the bottom of the tank. The weight of the water in the tank pushing down and forcing water out of the pipe is analogous to electromotive force, which can be measured, just as water pressure can be measured in this example, or it can be measured as volts in an electrical current. The water flowing out of the pipe and down to the water wheel is analogous to current flowing through the wire or in a circuit. The pipe constricts how much water can be flowing and is analogous to resistance. We can calculate the resistance based on the water pressure and the amount of water flowing. The water wheel is where work is performed and the energy is used. We can measure how much work is done just as we can measure how much voltage has been consumed. The current doesn't get consumed, just like the water in this picture isn't consumed. The water just accumulates in a pond at the bottom waiting to be pumped back up to the tank and used again. So current isn't consumed, but voltage is. As you can see, there is no more water pressure in the pond at the bottom of the tank. Here's another pictorial of these 3 characters. Mr. Volt is pushing Mr. Amp through the circuit, while Mr. Ohm is restricting the flow. There are two more important units of electrical power, the Henry and the Farad. The Henry is named after Joseph Henry, the American scientist who discovered electromagnetic induction. A coil of wire will initially oppose current while it builds a magnetic field, storing some of the energy in that magnetic field. When the magnetic field is full, current then passes unopposed. When no more current flows, the coil releases the magnetic field, converting it into a current, which then flows out of the coil. This is a very useful property called inductance, measured in henries. We'll look at coils in more detail in a subsequent video. The Farad is named after the English physicist Michael Faraday. A capacitor is a device with two conductors separated by an insulator. Current flows into the capacitor, but can't flow through it because of the insulator. It flows into the capacitor until the capacitor is full, and then current stops flowing. When current is removed, that is, the voltage push stops, the capacitor discharges and the current flows back out of the capacitor. The capacitance of a capacitor is measured in farads, denoted by the letter F. Inductors and capacitors are very often used together in electrical circuits, as they have complementary capabilities. For instance, a pulsating current can be smoothed out by a combination of capacitors and inductors, as we'll see in a later video. This concludes the video on the various terms used to measure the properties of electrical energy. Volts are the measurement of the force behind the electrical energy flow. Amps are the measurement of the amount of energy flowing. Watts are the measurement of the work performed by the push of the current. Henries are the measurement of the amount of energy that can be stored by a coil in a magnetic field. And farads are the measurement of the amount of energy that can be stored by a capacitor in an electrical field. The video on electrical components will show how these various measurements are applied. Please note any questions or concerns to be discussed in our online session, or email them to me at rolandksmith@gmail.com. We'll see you online.